Well, let's see the second example. Here we have a straight line passing through a point -2, 1 and having a directing coefficient, which is in fact the slope, a equal 3. The solution here, it's preferable to think about the reduced equation. Since we have the slope, directly we plug in the slope here, which is 3, to get y equal 3x plus b. We need the value of b, and we must find the values. We must have the values of y and x. As you know, y and x represent the coordinates of a point on the straight line. Here we have point A, -2, 1, as you see, belongs to D. So as A belongs to D, then the coordinates of A satisfy the equation of D, which is ya equals 3xa plus b. This leads to 1 equal 3 into -2 plus b. At the end, we get the value of b. After that, we just replace b by its value to get the reduced equation of d, which is y equal 3x plus c. If you are asked to find a standard form, you must rearrange these terms to get the standard form by this way, and this is the standard equation also of d. Let's see another example. A straight line d passing through a point b of coordinates 2, -1 and having s of coordinates 3, -4 as a direction vector. Solution, try to think alone. Okay, here we have, as you see, a straight line passing through b and have a direction vector s. Here the idea is based on, again, by placing m of coordinates xy on the straight line. And as you see, we have a constant relation here between two vectors bm and s, or mb and s. As you see, bm, we are going to find the equation in different forms, 3 different forms: standard, reduced, and parametric later. In the part A, I'm going to find standard and reduced form. Let mxy be any point on D. Xy in general, any point on D, which is unknown for us, not of unknown equation. We just know that it passes through B and has direction vector S. Then bm vector xm minus xb, ym minus yb, to get this, and the coordinates of S. These two vectors are always collinear as m moves on the straight line. And from collinearity, we can use this relation xy prime equal yx prime. This leads to this relation, and expanding, reducing them, putting them on the left side to get the standard form. And as I said, we are going to find the 3 forms, find the equation of D in 3 forms. This is the standard equation. In reduced form, just isolate y on the left side and taking all the other terms to the right side to get this reduced form. Okay. Now, in parametric form, remember that the general parametric form is x equal alpha t plus x point on D, y equal beta t plus y of a point on D. As you know, we are given point B on the straight line, so we may just directly replace xb and yb by their values, where alpha and beta, as you know, alpha and beta are the coordinates of a direction vector of D, and we have it, we are given it, which is as 3 minus 4. So alpha will be 3 and beta will be -4. Just plug these values here and these values here to get a parametric equation. It's so direct. Where t here, the parameter is called t here. Notice that we may replace the parameter by any letter other than x and y, sure. Usually we use the letters t, t prime, k, k prime, m, whatsoever. Okay, let's see another example. A straight line L passing through point A, and as you see from the figure helps to understand what to do, what relation do we have between vectors. I advise you to make a sketch for this. And L is parallel to another straight line whose equation in parametric form is given. Here the parameter, as you see, is m. So a direction vector of this straight line D is alpha beta, since it's in parametric form, so it will be -2, 2. Now, since L is parallel to D, this leads to say that V itself, which is a direction vector of D, is also considered a direction vector for L, isn't it? It has the same direction as D, since D is parallel to L, as I have said. Then we have a direction vector for L, and we have a point on L, and these are enough to continue as the previous example. X will be -2k, I named the parameter by k, plus x of point, which is 4, and y will be 2k beta t, beta parameter. Here the beta will be 2k minus 1. This is it. Now, in this example, last example, a straight line L passing through a point S and perpendicular, the straight line L perpendicular to another straight line. A direction vector of D, once you are given a straight line, I advise you to find directly a direction vector for it. That usually we use it for, that helps to find the equation of another straight line. A direction vector of D, since it is in standard form, is in general minus VU, and minus V is -4 and U is 3. Here, see, if you see in this figure, a straight line L is perpendicular to D and passes through a fixed point C of known coordinates. Again, we let M of variable point on L of general coordinates x, y, as you see. Think about what relation do we have between the vectors Cm and S. Clear from the perpendicularity of these two straight lines, we can notice that the vectors Cm and S are orthogonal. So we can easily find the coordinates of Cm and S, and since they are orthogonal, as you know, orthogonal vectors have special scalar product from previous chapter. The scalar product of S of two orthogonal vectors will be 0, and this leads to the relation between the coordinates, their coordinates x, x prime plus y, y prime, where x and y represent the coordinates of the first vector, and x prime, y prime the coordinates of the second vector, which is here's S. This leads to this relation, and expanding, reducing them to get a standard equation of D. Now, the second part of this, in this video, we are going to learn how to transform equation of a straight line, which is easy, as you will see. Let's change from reduced to standard, standard to reduced, which is very easy. Given a straight line dy equal 4x minus 3, this is, as you know, the reduced form. What about a Cartesian form, or standard Cartesian form? It will be, you just take all the terms to the left side and keeping the right side 0. It will be minus 4x plus y plus 3, or you may multiply both sides by -1 to get 4x minus y minus 3, as you see here. Both are true reduced form of equation of straight line T. Let's transform from parametric to standard, and then after that standard to parametric. The first case, we are given a parametric equation, system of parametric equations of straight line D with the parameter T, real parameter T. As you see, think about how could we find a standard equation of D. In standard, as you know, we don't have any parameter, we just have a relation between x and y, as you see. So we have to think about a way to eliminate T or remove T from here, the parameter. Here it is T. So we just eliminate T by solving the system. And here we have -2t, so we need +2t here, and this can be done by multiplying this equation by 2, and then to get this equivalent system. After that, we just add these two equations, the left side with the left side and the right sides together to eliminate the parameter. By this way, we will get 2x plus y equals 4 plus 1, which is 5. At the end, we get a standard equation with no parameter anymore, no parameter in this equation. And this is a standard form of the same straight line D. Okay, now let's change from standard. We are given here a straight line delta of standard equation minus 3x plus y minus 1 equal to 0. The rule says to write delta in parametric form, we just replace one of the variables, either x or y. Choose one of the variables, either x or y, and let it to be a parameter. Then we find the second variable in terms of the chosen parameter. Let's see how. In this example, for example, let x equal a parameter m. You may start by let y equal m. Then after that, replacing this variable by the chosen parameter, m or t or k, whatever as you like, you will get minus 3m plus y minus 1 equal to 0. This gives y equal 3m plus 1. By this way, as you see, we get x in terms of the parameter and y also in terms of the same parameter. By this way, if we combine these two equations in a system, put them in the system, we will get, in fact, the system of parametric equations of the straight line delta. It was in standard form. By this way, we changed it, we wrote it in parametric form. This is the end of part 3. Thank you for watching and see you in the next video.